Alright, so today we're talking about inverse trig functions, and you guys are going to be able to evaluate inverse trig functions. To do this well, successfully, and quickly, you need, again, to know your unit circle, okay? So, like I said before, please make sure you know your unit circle. So, before we get started, we talked about inverse functions before. So, real quick, we're just going to recap it, okay? Inverse. What do you guys remember about inverse functions? Yes?
Say your x is y and your y is x.
Your x is y, your y is x. Does anybody remember anything else about inverse functions? See if you answer.
You solve for y.
You solve for y after you do what? Switch what? Switch your x and y. So algebraically, if you had an equation to find the inverse, you would take your x and y, flip them, and then solve for y. What was the notation for inverse? How about that? Who remembers?
F of x, but the negative exponent.
And the exponent was a -1. Very good. What does an inverse look like? Like if you were to graph the original function and the inverse function, what would it look like?
The opposite.
Reflection over what?
X. Over the diagonal.
What was that diagonal thing?
Linear slope.
Huh? Y equals x. Y equals x. So you switched your x's and your y's. X became y, y became x. When you graphed it, that line y equals x, you reflect it over. So if the graph went like this, the inverse reflected over it. Okay? And you will always find the points on your inverse by switching your x and y's. Okay? That same concept applies to the graphs of your trig functions. However, in order for a graph to have an inverse, something had to be true. This is another thing for inverses. Who remembers? That point of origin? Something else.
It's like something plugged into the inverse had equals 0.
It has to be a function.
I forget.
That's how you would determine if two functions were inverse of each other. You said
It has to be a function.
it has to be a function. Almost there.
X's cannot repeat.
Any strange solutions? X cannot. Okay, we're getting there. Come on.
Y is
You already got that? There was something that had to be true. Come on now. Function. What makes something a function? It passed the vertical line test. So for inverses, the horizontal line test, which means that it had to be 1-to-1. It had to pass the vertical line test and the horizontal line test. Now, it has to be 1-to-1, passing the horizontal line test. That's when you have an inverse for a function. However, sine, cosine, and tangent, they do not pass the horizontal line test. So you have to restrict the domains for each of the functions in order to have an inverse. So what we're about to do is we're about to take a look at the graph of sine, cosine, and tangent. We're going to restrict the domain so that way we can find the inverse of these functions. So open up your booklet. You should be on, it should say sketch sine function from, we're good? Okay, now, we have to complete this table of values. This is coming from your unit circle, okay? This is coming from your unit circle. You have 0. Pi over 2 is located where? At 90 degrees. Where is negative pi over 2? At 270, okay? So we're basically looking in between these values, okay? What is the sine of 0? 0. What is the sine of pi over 6?
30.
It's going to be 1/2.
I was so close.
Because sine is which value? Which coordinate?
Y.
The y. What about pi over 4? Good. What about pi over 2?
1.
Is that 1? Now, yes, the one in the middle is missing. Why? To be honest, I'm not even quite sure. But, yes, it is missing the pi over 3. Let's just throw it in there. What is the sine of pi over 3? Good stuff. Now, let's go the other way. When you go to the negatives, you're going in the clockwise direction. So, negative pi over 6 is right here.
Negative
So, it's negative what?
half.
Negative What about a negative power 4? And a negative power 2? Negative 1 power 2. So, that is the graph of your restricted sine function. Normally sine looks like this, right? That's what sine normally looks like. But, in order for it to actually pass the horizontal line test, we have to restrict the domain. So we're only looking from here to here on the graph. That's what we're looking at. Okay? So let's graph this real quick. We're going to label our axes and graph this function. Do you have to use up all the lines? No, you don't, but I'm just doing it for emphasis here. It is half of a period, yes. So, plot it. You got 0, 0. Power 6, 1/2. Graph this. Graph this now. This will be power 6, 1/2. Power 2, 1. Negative power 6, 1/2. Negative power 2, 1 is the graph of sine. This is what it should look like, guys. I mean, it looks just like it. Okay? The reason why my 1/2 is right here is because I made this line positive 1. So halfway would have been 1/2. Okay? Depending on how you labeled yours might look different than mine. What is the domain of this function, of this restricted sign? Negative pi over 2. Are they included?
Yes.
What's my range? Are they included? That is going to have to be your domain if you want to do any type of inverse work with sine. That's going to have to be your range. So, if you think about it, does this graph have an inverse function?
Yes.
And it's yes because it does what? It passes both tests. It passes the horizontal line test and it passes the vertical test. So, to graph your inverse, what do you need to do to your points? Switch them. So, that means these are going to become your y's, and then these are going to become your x's. So my horizontal axis is now going to go from negative 1 to 1, and then my vertical axis is going to go from pi over 2 to negative pi over 2. All we're doing is we're taking the x and y points and switching them. So when x is negative 1, y is negative pi over 2. When x is negative 1/2, y is a negative pi over 6. When x is 0, y is 0. That hasn't changed. When x is 1/2, y is pi over 6. And when x is 1, y is pi over 2. And this is the graph of your inverse. What is the domain of this pink graph here? Negative 1 to 1. What's the range?
Pi over 2, pi over 2.
And if you notice, the domains and ranges have switched. That's because it's the inverse. Everything switches. Remember, x meant domain, y meant range, correct? So there you go. This is the graph of the inverse of sine. You use these values to determine, to evaluate sine inverse and things like that. Okay? So if you flip back to the front, when it said properties and for the domain, okay? When you have the sign of sine inverse of some value, it's going to equal x, but that's only if it falls on this domain, negative 1 to 1. Make sure you fill that in. Vice versa. If the sine inverse of the sine of a function, a value, it will equal that value only if it falls in between negative pi over 2 to pi over 2. We will talk about that in a little bit more detail once we get through all three of them. Okay? Now, cosine. Yes, we gotta do cosine and we gotta do tangent. Let's go. We're gonna do the same thing we did before. Unit circle time. What is the cosine of 0?
1.
1. Pi over 6. What's the cosine?
Negative 3 over 2.
Okay, I heard like two different things. What is it? Square root of 3 over 2. What about pi over 2? What is it? I mean pi over 4, I'm sorry. And then pi over 2? 0. What about 2 pi over 3? It's negative.
Negative 1 over 2.
Negative 1 over 2. What about 3 pi over 4?
Root 2 over 2.
Root 2 over 2. Nausea unit circle is crucial. What about 5 pi over 6? What's the cosine? Negative root 3 over 2. And what about at pi?
1.
Negative 1. Okay? Think about cosine. Cosine normally looks like this. Does this pass the horizontal line test? No, so we have to restrict it. We are restricting it right here. So we're only looking at this part of the graph. This part alone passes the horizontal line test, doesn't it? That's why we only use these values here. Okay? Let's graph this. Okay? Let's graph this. We'll have 0, and then pi. What do you guys make? Graph this. Graph those points. What's the domain? 0 to pi, included or not included? That is a 0, not a theta. What's the range? Included? So then the domain and range of the inverse would be what? What would be the domain of the inverse? Negative 1 to 1, and the range? 0 to pi. So that means all these are getting flipped. So my x's are now going to be my y's are going to be my x's. So when x is 1, y is 0. When x is 1/2, y is pi over 3. When x is 0, y is pi over 2. And I'm just doing the rest. When x is negative 1/2, I'm at 2 pi over 3. And then negative 1, I'm at pi. And there's your inverse. So here, for these particular properties, when you're dealing with inverses, when you have the cosine inverse of a particular value, it will equal that value as long as it's in between negative 1 and 1. And the cosine inverse of the cosine of a value will equal that value as long as that falls in between 0 and pi. If it doesn't, then we cannot answer the question. It's not possible. It does not exist. It's not possible. There's no answer. Okay? So that's why you have these restrictions here.
So, if it doesn't fall within that domain at all, for any of them, you can just instantly just say no, it's not.
Right. Not possible in E, in A. Don't leave it blank because then we'll think you don't know. See what I mean? Okay. Last one is tangent. Let's do this. Quick change you need to make. Nope. Okay. Tangent is what over what?
Y over x.
Y over x. So we gotta look at a couple of these things on the unit circle here. Let's start with the positive side. What is the tangent of 0? The tangent of 0. That ordered pair is a 1, 0. So y over x would be what? 0. tangent of power 6? Square root of 3 over 3, because you have to rationalize. What about power 4? What is it? 1. And power 2?
Undefined.
It is undefined, which means what's happening there?
Vertical asymptote.
Vertical asymptote. We've gone over this, especially since we just graphed tangent and cotangent. Let's go the other direction. Let's hit these up. Okay, what's this ordered pair right here? Root 3 over 2, negative 1/2. So if I do y over x, I'm going to get the same value except it's negative. What is the tangent of negative power 4?
Negative 1.
Negative 1. And then negative power 2? Undefined. So I got vertical asymptotes. I have a 0 here. And I'm only going to graph what I know I can graph, so I don't have to pull out a calculator. So at power 4, I'm at a 1. Negative power 4, I'm at a negative 1. And here's the graph of tangent. Now, tangent is already restricted. We just can't look at all the other pieces of tangent. But one little curve of tangent in between the asymptotes is exactly what we need to do to restrict it so we can do the inverse. What's the domain of this? Negative power 2, but not included. What's the range? This one, it keeps going after this, doesn't it? Forever and ever. Negative infinity to positive infinity.
As long as nothing happens.
So, what is the domain or range of the inverse? What's the domain?
Negative infinity to positive infinity.
Negative infinity to positive infinity in the range. And they're both
Not included.
not included. So let's do this one last time and then we'll actually get to some evaluating. We're going to switch these. So this becomes my x's. These become my y's. So at power 2 and negative power 2, I'm undefined. So instead of having vertical asymptotes, they're now going to be horizontal. And now my curve is not going to go up and down, but it's actually going to run left and right.
Would that be a function though? Would that still be a function?
Yep. Because the original one passes the horizontal and vertical line test. Let's see. So at power 4, we're at 1. I'm sorry, at 1, we're at power 4, and then negative 1, we're at negative power 4. So that's what the inverse looks like. So, just like the other ones, when you take the tangent of tangent inverse of x, it only works if it's all real numbers, so there's no restriction on that. It just has to be real. But when you take the inverse, tangent inverse of the tan of a value, that value has to be in between this interval. And correction, make sure that these are parentheses, because they're not included. These are not included. Alright, so we're going to evaluate these. Some with the calculator, just so you can get some practice. This is actually super simple. And then some without the calculator. The ones without are going to be the ones that you really need to know how to do. So quick. Grab a calculator. Make sure you are in radian mode. So to get inverse of sine, you just do second button and then the sine button. You literally just type it in. And you're rounding to 2 decimal places because that's what it asked us to do. So what's the answer? Negative 0.83. You guys have the rest. I know you do. Okay?
I didn't know we were doing it.
second for the.
Yes, you press the second button and then you press the trig button, whatever it is.
Yeah.
And then you type in the value. If you did not get this, that means you are not in the right mode. It should be an error because look at this. Remember, before with cosine, it had to be in between -1 and +1. So it needed to be an error message because 1.5 is bigger than that. Okay? So, this one, yes. This one is not possible. Not possible.
But that's only if it's off.
Negative 4.
So, you guys got 1.13 for this one and -4 for this one? As you should. Now, one thing I do want to point out, especially with the last ones, okay? Look at this format. Look at that format. This is the same as this was. Okay? So it was 10 and the tan inverse of -4. This right here is kind of like this property. So basically, these cancel them out and you're just left with -4. As long as that value is a real number. Does everyone see that? So you really could have done that without your calculator, but you had no property. Okay? It works the same way with this one. However, you gotta do a little bit of manipulation. And you're like, what? You see what I did here? I just broke it down, right? So I could rewrite 2.36 pi as 2 pi plus 0.36 pi. What is the sine of pi over 2? I mean, sorry, the sine of 2 pi. That's 0. Okay? So essentially, this is the same thing as saying the sine inverse, the sine of 0.36 pi. If you do not believe me, right now type in 0.36 pi, and not 3.14, I mean the pi button. Type in 0.36 pi. Don't you get 1.13? Now without a calculator, this is where you have to know the circle, or at least the graph of their inverses. And when you're doing this, you basically are trying to figure out where on the graph of sine and cosine inverse is the square root of 2 over 2. If you need to flip back to the table where cosine was, that's fine, do that. But where on the inverse is cosine of square root 2 over 2?
Pardon the interruption at this time.
Yes, it is pi over 4, and that's your answer. Okay? If you remember that cosine is only restricted to 0 to pi, you can think to yourself, where from 0 to pi is cosine root 2 over 2?
Wait, why would it be
It's in the middle.
Pi over 4. Because look back at cosine, right? We're only looking on this interval alone, because that is the domain and range. Okay? So we were looking, okay, so where is cosine a positive root 2 over 2? Right here, pi over 4. Okay? Now let's look at the next one. It was a tangent negative root 3. The tangent inverse of negative root 3. It was what? Let's go back and look.
That's negative root 3 over
That was negative root 3 over 3. So it's actually,
5.
mm-mm,
In the middle.
it was the one that wasn't listed here.
Negative 5.
Negative pi over 3. That's that exact value. Exact is the giveaway. Exact means unit circle, or it means one of the properties.
And there's not one for the
Huh? Now let's look at this one. Ooh, this looks like that property, correct? Look back to the front if you need to remind yourself.
There is none. It has to be.
Wasn't there one that was something like this?
Yeah,
But it's what?
It's lower than negative 1.
It's lower than negative 1. However, it actually still does work. Huh? It's actually a positive 1 point. Don't believe me? Plug it into your calculator. I know it says don't use it, but if you don't believe me, plug it in. And the only reason why why this works is because it's a normal cosine on the inside, and you're taking the inverse cosine on the outside.
Would you write, is that a CA?
That's a C.
Oh. The last one, like, looks like C-U-O or C-O-S. I see it now.
I just rewrite the property so I didn't have to flip back and forth between things.
We're doing the rest of
Okay?
Wait, I thought cosine has to be in
25. So we're going to do the exact value of the following trig functions. Yes, A through N. A through N. I'll give you guys a second to write these down. So, real quick, for those who don't know, arcsine is the same thing as sine inverse. So arcsine, arccosine, arctangent, they all mean basically the inverse. Okay, it's just another way to write that. So I don't want anyone to be confused about that. Are we clear?
Yes.
Cool stuff. So, find the exact value. Exact means that either value is going to be exactly the answer or it's going to be on your unit circle. But you got to be aware of your restrictions. Remember, sine is bounded in between what values? The inverse. The domain.
Pi over 2,
Negative pi over 2 to pi over 2. Where is cosine bounded in between?
0 and pi.
0 and pi. And then tangent is bounded in between what? It's the same thing as sine, but they're not included. So you have to think, from negative pi over 2 to pi over 2, where is sine 1/2? Where is sine 1/2? Pi over 6. So the exact value of this one is pi over 6. And that's what you do. That's all. But you got to remember, these are the restrictions. Let's do a cosine one. Let's do G together. We have to ask ourselves, cosine to the -1 of negative root 2 over 2. Where, from 0 to pi, because that's the restriction for cosine inverse, is it negative root 2 over 2? Where is that?
3 pi over 4.
And if you're like, gosh, how do you get it so fast? Hey, unit circle. Let's do a tangent one. Let's do N. You'll do N. We're going to do N as in Nancy. What's the tangent inverse of -1? Where, from negative pi over 2 to pi over 2, is tangent a -1? It's what?
Negative pi over 4.
It's negative pi over 4. Because you're only bound to this part of your unit circle. Up here is a positive one, so down here is the one that you need. Yes. Okay? I want you guys to do the other ones. Now, before you leave. Do it now.
Oh no, we're not talking right now.
We're gonna need your workout help to get this board out.